One is PPT one.
Okay, so this session is mainly based on IoT and AI based centralized management system. But few slides only I will talk about this AI and IoT. And after that I will show you one case study. Means AI based control for the particular management system I will show. So that will be completely more some interested thing will come back. So few slides will be based on this IoT and AI. So why we are going to use this one? What is the use of that? And what is the purpose of that? And then I will show you one AI based solution. What I have done also, one also I will show you in this AI for the many of the control purposes. So this main question is what we are going to discuss here. The question what we are discussing is why we are going to use this IoT. If I think we will use IoT and AI, then what will be the things we can? First of all, where we are going to use this AI, IoT. IoT will be using communication channel, and AI will be using central control room. In the last lecture I told. So meter data management. So inside this we will use this. Is on the communication channel we will use IoT, and then on our meter data management system there we will use our this artificial intelligence. So what is the main you will see the benefits of this? This is the monitoring, control and optimizing. These three things you will see. Monitoring is what is happening there, and that is according to your expectation or not. Means system is healthy or not, some fault is going to happen, and whatever. So this is the monitoring thing. If anything will occur beyond your expectation, then you will take any action. Right? That is your monitoring side. Mostly you will see the fault detection side or health monitoring side. This is you see, and this is for the planning purpose. This is for the safety purpose. Another side you will see the control. So control is according to the current event. Means who wants what amount of power, who wants what type of power, right? So that one you will control here. Means you try to fulfill the user demands, try to fulfill the load demands. Those are the things you do here. Controlling. You are the controller mainly you will control the power supply system, you will control the power generation system, you will try to control the different type of electric power plants, for example SPC and all that. Also for the voltage matching you will trigger the capture and transformers and all that. So those things you will see here on the controller side. The last one, optimizing. Optimizing is you will try to find out the most best solution for that. Most of the time, these are things will not reflect in the terms of benefits benefited for user side. These are the optimization will benefit for utility sides, right? For example, I am generating power and send it to in a particular location. But the question is, when I am going to send it, what should be the my path? Right? Path means we will transfer the power through a transmission line, right? And the system is an interconnected system. We have different paths. So through the different path, we can supply the different amount of power. So we will calculate. I will calculate the total losses, and then I will choose which path is suitable for me, so that the losses will be less, and then like that. Otherwise, if I will go with a different path where the loss is more, consumer will be the same. If I will choose the different path, whatever path I will choose, consumer will pay only what amount of power they will consume, right? But, but my loss is in terms of losses. So what path I am going to choose, what path I am going to select, right? So that's why. Also, I cannot say that this is a radial system, so one way I have and then through that they will supply the power. Not like that. This is an interconnected mesh system, the grid is a mesh system. So in this situation, we have different paths. So our task is to choose the path. Also, when I go, so from this particular location, load, the expected load is too much, right? For example, peak load is suppose 200 megawatt. Suppose, then what is the task? May I put a line for the 200 megawatt path, or may I go for a average according to the average load? And only when the load is more, then I will choose the different path. Right? So this is the way. Means suppose you have an area which load is suppose 100 megawatt demand, average demand, and the peak demand is 120. So one option you will say put a line for 120, or another option is put a line for 100, and then during the 20, which is for the short duration, take other path. That is also way, right? So this is optimization. What I should do. So this is for the operator level. Also for the planning of the plants, which plant. Also for the planning of the plants, which plant will generate what amount of power, right? So this is also we should plan. For example, we have a different plant at different location. Also, we have multiple nodes in between. So, who will generate what? What amount of power? That should also be part of this optimization. So, all these things will happen here with the data management side, also utility side, like that. But the controller and the monitoring is mainly you see over user side. User will benefit from this monitoring side. Okay, because we have the user is vulnerable. In this situation, our monitoring is will be useful for their monitoring. Okay. And then according to this, what the things will come in the picture? So energy efficiency will increase, reliability will increase, and sustainability and system will be more and more sustainable. Already I discussed in the last two days. So you will see the IoT, right? What is IoT system meaning? IoT system is the combination of communication device, right, and your display system as well as data exchange monitoring platform. You can say that this is combination of all these three things. Means first of all you will collect the data, then you will communicate through transmit your data, and then you will and also you will use one system will be required so that you will maintain the privacy, also to maintain the data loss and all those things you will maintain here. So for that purpose. So here you will see what the things required. Required one smart meter will required. Meter for measurement. And then required sensor. Right? Sensor will give you the real-time information. Sensor will not calculate anything. Meter will calculate. For example, sensor will give information about voltage and current value. But your meter will collect the data from sensor and then you will do all this calculation. What is the power here? What type of power is this? In the next moment, what type of power is consumed? So it will add cumulative power. You will see that, and on that basis you can see what amount of energy you are going to consume on hourly basis, minute basis, whatever. So the meter, sensor, actuators, and communication modules. So these are the part of your this IoT system, right? Modules. So these are the part of your this IoT system, right? So you will collect the data through the sensors and meters and all that. Then you will change the data according to the requirement, and then you will transmit through the communication module. But here, on the communication side, we are going to use internet. But yes, in the current situation, our grid is not using any internet path for the communication. But yes, we can do that. Right? This is the thing. Next. So you have the key components and smart meters you will see. Okay. Then you will see the sensors, actuators. Actuators are mainly for control your different types of devices what you are using. So it will control that. So what should be that? Maybe for the lighting purpose, maybe for the AC termination transmission system side, and whatever other smart applications you are using, right, at your home. So those things. So you can control them. So control the power, control the mode, control the uses, all these things in the secret in the many people try to minimize the energy usage in this, right? And the last thing is the communication networks, right? In the communication network, we will choose here Wi-Fi, and then otherwise we will choose our internet. Yes. So if you see the benefits of it, the benefit will be from your reduce the cost, right? This minimize the loss. If you will do these type of things, so the cost will be improvement here you will see. High energy efficiency, you will see high energy efficiency again related to the losses. Losses is less, so efficiency will be more. Efficiency will be more, the cost will be lesser. Also, remote access, yes, you are going to use your IoT system and all that. So remotely you can take the action and you can do the things what you want. This connection, disconnections, or whatever you want. Or also from the communication purpose, you can use that. You can say that what is going to happen there. So remote access, you will see that. And also you can create the reporting. Report is annual report, monthly report, whatever reports you want, you can create and you can share with the consumers, right? For that purpose, this is also useful. Understand the consumption pattern. So this one. Understand the consumption pattern. This will be help you during your load forecasting, during your generation planning. So this pattern is useful for that. Understand the consumption pattern, right? This will also help for theft detection. I mean, someone is doing some wrong thing, so you can also detect from this pattern behavior, right? So pattern behavior means last month your use was something else, and this month you used it and decreased significantly. So this is a questionable thing, right? And then again, this lower is maintained for a longer time. Then this is a questionable thing. So that way you can detect so what is going to happen, and because of what reason the power consumption is decreased significantly. Yes, there is a chance that we have started using renewables because of that consumption has gone down. But it's okay. But you can predict it, you can confirm it. Where is this and why is it happening? So this one, these kind of things. And last one, easy accessibility. Easy accessibility means your data, your monthly big payment process, or maybe also your regulations as well as your protections. All these things easily you can monitor, also easily you can pay, and all these things. So like that. So this will be helpful. Okay. So major benefit is real-time monitoring, predictive maintenance. Predictive maintenance means you can predict the maintenance requirement in the entire system. But in current situation, whatever maintenance we are doing regular maintenance, or you can say time-based maintenance. Means one side, some station have plan, so monthly maintenance should be, so monthly date is 41 or maybe 1 or maybe 10. So on every 10 month of the year, he will go and then maintain and check, and then he will come back and make a report like that. And the maintenance for the maintenance for the your insulators, maybe circuit bus bars, maybe transformer, and all that. So currently we are following the time-based maintenance. What is happening in between? No one is going to worry about that. Bother about those things, right? Because even some fault occur, then someone will trigger and is going to start thinking. But in this situation, your maintenance will be predictive maintenance. System will detect. So yes, maintenance is required, then maintenance will be performed, right? So maybe the maintenance will be on the lower frequency or maybe on the higher frequency. Maybe system is working fine, so not necessary to go on monthly level. Go on after the 6 months or 1 year, whatever. But if the fault is occurring on the lower frequency, means after the 7 days, suppose something is going to happen, and if you have the information, then again you will go for the maintenance. So predictive maintenance will be here. This is a very good thing for the health of our devices, what are the devices we are going to use in our substation or maybe generating power plants. So there this predictive maintenance will be save the time as well as save the energy also. For that, this is good. Enhance the efficiency. Enhance the efficiency means the one safety. So you are planning how you are going to plan your production, or how you are going to plan your generation, as well as your transmission. Transmission, energy transmission. Through which path you are going to flow your power. So that's why this is very much important. So in real time data, if you have the real time you can think about the load, and then according to that you can plan also. So that's why this is efficiency. Cost sharing is also to losses, energy loss, then the cost will be the same. As far as cost sharing is in the terms of your other aspect also to the maintenance, if maintenance is predictive, so definitely the maintenance will be less. So the maintenance cost will be paid also will be save some like that will you can learn. Key applications of IoT here in this system. So in this system, we will use start. We will start from here. We will go for the smart lighting system, temperature, and air conditioning, and all these. Then this is our device level. Actually, what are the smart devices we are going to use? So it will link to the smart meters. And then meter will communicate the data with the central control. There we will go for the energy monitoring system, and then this monitoring system will try to minimize the energy resource, right? Through the proper algorithms and all the mathematics. So all these things. Another is AI. AI in the energy consumption. AI means what? Artificial intelligence, right? What is the use of this one here in the energy management system side? Whenever I am talking about the different types of tasks, means prediction and then for identification or digital monitoring, how you will do that? Definitely you will use some mathematical tool. AI is nothing. AI is just a mathematical tool which you can use anywhere, right? So this is also the case. So this is for that purpose only. So here by using the machine learning or getting neural network formula optimization. Optimization will be the classical mathematics based optimization or getting data analytics optimization you can go for that. Or heuristic optimization you can use it. For the prediction, for the prediction purpose, so we predict the fault, predict the situation, for that purpose you can go for. Also identification of the identification pattern. Identification means here user behavior you can identify, fault identify you can go for that. So those things you can do. Identify the pattern, right? Identify the pattern from according to that. And then lastly, automate decision making process. Automate decision making process is suppose you are planning for predictive maintenance, right? So this will give you the information, information. So yes, you should go and go for what? Suppose the predictive maintenance system saying, okay, go for the maintenance of the transformer. A transformer where? On the proposed relay side, on the transformer coil side, a transformer insulator side, transformer cable side, where? So through this, you have the information about the transformer related current, power, voltage, then you can identify where is the fault and where is the fault may be, right? You can predict the fault, not exactly, but you can predict that, and then you will try to give this information to the maintenance side. So they will try to sort out do this, right? So those things. Then automated decision making means whenever any severe thing will occur in your grid, so that time not required any manual control, right? Immediately the system will realize, okay, this is a dangerous, this is faulty, then immediately isolate those systems, right? So this type of things you will see inside the grid. So that's why you sometimes you will see the smart more popular word is self-healing capability. Self-healing capability means what? Whenever system will realize some fault is going to happen, then immediately system will cut out those faulty area from the system, and the rest healthy system will work without faulty, right? So these are things. But these are things can happen also in the normal grid. What is the difficult thing here? Difficult thing is whenever you will remove a faulty area, then you will realize that your generated power is more than your load demand. So at the same time, when you are removing the load, at the same time your generation should go down so that the only generation and load should match, so that your frequency and voltage all these match. So this is important. In the matter of techniques, you can go for like machine learning, neural network, and then optimization techniques you can go for that. Every these three types of tools are very much popular, but each tool has own merit and demerit. You can see that. Is here machine learning side. This is very much popular for your if you have a historical data, then you can take the data and then train it. Training means what? What is the meaning of training? Training means you are creating a pattern inside. Pattern inside your system, or you can say by using a pattern you are going to create one library. Library of pattern means something. Library of pattern means what? Suppose if you have a fault data, suppose some fault happened, then voltage waveform is like this. And then suppose the fault, what type of fault is that? Suppose you have assumed that line to ground. So voltage waveform is like that. Suppose the line to line fault, then that time voltage is not like that. Voltage is supposed to be this. Patterns are different. Similarly, like that, different fault have different behavior. Behavior not only in the voltage. If the voltage is not suitable, then you can go for the current also. Then you can check the current waveform and then try to find out the most suitable pattern for a particular event. So event is this fault, or any other fault. So you can create a different signatures or library and you will save inside your system. Whenever anything will occur, so that time you will get the data and match with the library. Match with the library where this data is supposed to which type of pattern. And then you can guess, okay, this possibility is this type of fault is there. And data will not only the voltage and current. Sometimes you will use the classical mathematics to identify that. Suppose this is the waveform of the voltage, right? This is the voltage waveform of the voltage, but in different system. More or less remain same. So you can use the mathematics. Mathematics is what you can go for the use this information, then go for the positive sequence component, negative sequence component, zero sequence component. You can find out from here. If this is the waveform, then you can go for the Fourier analysis. Then you can identify what is the first harmonics, second harmonics, third harmonics, and all that. Like that way, you can go for that. So same waveform, you can use the different mathematics to find out the different aspects from the waveform. Same waveform will give you information about the positive sequence, negative sequence, zero sequence, and all harmonic components. All you can collect from here and put in a library. Then go for the next one. This is the fault. This is the waveform. Ideally, it will looking same, but when you go for again all this sequence data, then match and then see in this situation and in this, but where is this difference? Then you will realize in this situation, if zero current consequence is zero, is available. In this situation, your zero sequence components are not available. Like that way. Maybe anything else also. So you will say that yes, these are the key factors. Wherever it will happen, this will be happen. Right? Like that way. So different fault, you will create a different signatures and you will save inside the library. And then once the library is ready, if your library is bigger, then it means you have a lot of information and your system is more and more robust to handle all those different types of faults. So these type of things happens in the machine learning. Mainly you will do these kind of things here. And after that, when you will collect the data in real time, again you will go over all this fundamental classification and go in the library, match and check. Right? Match and check. The data are matching with which type of fault. Right? And then on that basis we predict it. So this is one of the part of machine learning. Neural network. Neural network is very similar to this, but some hidden parameters are also. Inside in this neural network, you can merge two data and create a third data. Right? You can merge two data and then create the third data. So we can say inside the machine learning neural network, you can see some hidden layers. Sometimes you can see the hidden layers also. Hidden layers means in the neural network you can see that. If this two data is not sufficient to identify this third, so what you can do in the neural network side, you can create third data. How? Just add them, and then just make it after adding. Suppose here you will see there is a 0 and something like that. So this is third data, right? Which you have created. It's a third waveform which you have created by using the two pattern or three pattern, and then this hidden waveform will be inside your neural network. So called hidden layers of the neural network. This is hidden layers of the neural network, right? So hidden neural network is very similar to the machine learning, but the problem is the advantage in the neural network is you can create your own waveforms also. In machine learning, you will not do that. In machine learning, only whatever data will come, you will process it. But neural network, you will also generate different data, like available data, and then you will check again different aspects, and then you get the library, save it, and then you confirm it what is going to happen. These are the things you will see here in the neural network. So this is based on neurons, and these are very much, I will say, very same. But the problem with the neural network is this is a little bit more complex. Complex on the algorithm side. Another side is computational burden is higher here because here only you are going to create one library and then process your data. But this time library size will be bigger because one of the initial library as well as you are getting the data and then those data again you are processing. So your library size will be very much bigger. Right? So those are things you see here in the neural network. And then lastly, optimization. This is completely different from this. This optimization algorithm is recursive optimization techniques. This technique is not for the prediction like these things. This is mainly for solve complex mathematics. Complex mathematics means what? Is any mathematical problem which we cannot solve through the classical technique? Is it possible any mathematical problem? So we cannot solve that through our classical mathematics methods. Okay, I'm writing a problem just to suggest the solution. Very clear. So this is the problem. Problem is simple. Problem is single variable. This is not plus. Right? Not greater than you. The question is, what will be the value of this? What will be the value of x and y? You can say. At what value of x and y this function will be maximum? Suppose I am giving the range also for the x. Suppose giving the x range. So suppose I am giving and y I am giving. So at what value this will be maximum? We have to take this. Simply place this value and this value. You can place here, you can say that this is maximum. Okay, you have solved it now. You know the answer, what is the answer from here? 4 plus 7, 11 is the answer of this question, right? Yes, sir, 11 is the answer, right? Or something else? Okay. But the question is, okay, you solved it. The question is, how you have solved it? What is the name of this method which you have done? Optimization. Optimization. Here we have not done any. We have done the solution. Okay? Gradient method. Actually, gradient method again requires so many mathematics. You have to differentiate and particular equation, right? So I'm not talking about how you will solve. You have to immediately say this is the answer, this is the answer. But at what basis you your answer? You have decided this answer.
No, which is the way to
Yes. You know the boundary actually, so boundary on the boundary you have tested and you say this is the thing. So what is the name of this method? It's actually graph method. Right? So when you apply the graph method, it will also the same thing. You will plot the first graph here and then you will plot this graphs also and then you will see all those corners. Corners, what mean those corners? These are the corners, right? These are the corners. So all these corners you will put in the plot and then you will see the answer. Right? Like this way. Just go on the next one. Suppose this is another one. This is the problem. And then I am giving another variable here. This one, we can solve it.
then you will get 3 graphs out there.
3 graph, 1 graph, 3 dimensional graph. Yeah, 3 dimensional graph, and we can solve it like that. 3 dimensional graph, and then we can go for this also these 3 graphs on the same plane, and then we will see the active area, and then all those corners, and so we can conclude yes, this is the answer. Question is not question. Just assume one more. This time what we have? Question is here. Is this time how we will solve? How will this work? I want solution. I don't want yes. I want solution. Just tell me what mathematics I have to do to solve it. You know any mathematics?
Lagrangian method.
What?
Lagrangian.
G. Lagrangian method. Lagrangian method is okay. No. Lagrangian method is also again the disk. So you can iterate. I want pure classical mathematics, so which will give direct pure practical answer. I don't want to guess now. I want classical mathematics to solve it for the perfect answer, not approximate answer. So finally, we realize that we don't have any method. We don't have any method for that. So this is the situation where your classical mathematics will surrender and then require some additional technique to solve. And this is your optimization. This is your optimization. Only by using optimization you will solve it. Yes. Inside the optimization, again we have the two options. One is the classical mathematics based optimization, just like a graded descent or Lagrange multiplier techniques. Neural networks also we Newton method we can use it also for that. Or we can go for the better based optimization. Right? So any technique we can use it to solve it. What is this technique actually? Those techniques are nothing. So we go for the techniques in the optimization. The simple way is that initially you will choose the random values of this, put here, and note down this value, choose another, note down this value, like there's a two type of feature, then conclude that out of all these three, which is good. And then next time, try to change those values slightly by base on the basis of available solutions, right? On the basis of available solutions. So those type of things happens in the optimization technique. So that's why if you don't have any platform or any facility for research, so best way is this one. You can start from this side. You can start from this optimization. You can use this optimization technique for different programs for the communication side. And if you want to make a good communication in a high impact factor journal, so optimization is good. Okay. First of all, work on the problem. First of all, try to find out the most complex problem. Then move on to solution. Solution is same. It's optimization. For example, I'm saying. So the problem is, so I have two generators. I have two generators. Generator A, generator B. Generator A have this much of power generating capability. Generator B have Y power generating capability. My load is C. So how much I should generate? Then you will see the distance between load and generator A, load and generator B. Then you will calculate the losses, and then you will say, yes, this loss is this much. Then this generator will give this much. This generator will give this much. So this type of problem is easy to do. What you can do? You can go for higher level. Just assume these generators are not generators; these are solar plants. It means the generator will generate that much what I am going to calculate is not sure. It will depend on the climate condition. It means the calculation will come with some some uncertainties. Right? Some uncertainties. And the value of uncertainty will depend on the solar environmental conditions. Problem is little bit complex. Next time also, generator 3 is wind generator. Wind generator is going to committing to this much of power. But this commitment will fulfill or not, it will depend on what? Wind speed, right? And all that. So that will also include in this system. And this time you will also consider mismatch or uncertainties. Uncertainties means how much power, what the commitment is, and how much lower or higher may generate from this plant. So this is your uncertainty. So what you will do, when you will plan your total load, that time you will include that uncertainty also as a load. And you will be ready to handle those things. How you will decide this uncertainty? You will use some forecast algorithm. First of all, use the forecast algorithm to predict the wind condition, and then use your optimization technique to find out your load planning and all that. So like that way. So if you don't have any resources and you want to get some publication, then you can go for this optimization and power system based optimization. Don't try to use this optimization with your power electronics side. If you will go for the power electronics in journal level, no one will appreciate it. But in the power system side, everyone will appreciate it. But sometimes, for example, sometimes I have seen some publications. So okay, you have a converter, you have a PI controller. PI controller is KP, PI, and all these are variables. So you are using one optimization technique to find the value of KP, PI, and KP, something like that. And you are writing on paper publication. Definitely it will reject. No one will appreciate this. This is in the journal level. Conference is okay, but not on the journal level. What do you think?
Sorry, when I search something optimally, you can design.
Huh?
Can design optimally.
Optimally can design, but in practical condition, KP values are always we decide on the basis of heat and drag.
Practically,
Practically,
you can design optimally.
you can design that one, but once you design it, then you check. that value is going to work? No. Why this is? Because during your designing, you will consider your transmission, you will consider the connecting wire and certain resistance. You are going to think about the switch have a own resistance. You are going to input on capacitance. Capacitance have internal resistance, internal own resistance. And these things you have no idea about these things. So whatever mathematics you will do, mathematics will
is
be
considered as a states.
huh?
Capacitor value, inductor value is considered as a states. So we can optimally for using states.
Capacitance value you can include it, but not resistance of the capacitor.
For example, I want to measure the capacitor voltage.
Yeah,
So
capacitor.
it gets states.
Yeah, but that voltage in technical condition it will get that voltage.
No, it will get it. Actually, capacitor voltage will measure by sensor.
So you can measure it, but the question is, if you have a circuit, alternate circuit you have, then how many sensors you will use, and where you will place your sensor. Just as making one small DC converter, simple DC converter, and making on your board. See this boost converter most suitable or single. This is your DC supply. This is your DC supply. First of all, you are going to the inductor. This, then your switch is here. Then you are going for one diode here, and then you are going for one capacitor here, and then you are going for this load. So this is your load point, right? And now you are going to control what this, right? This time you will calculate wherever you will place your sensors. One sensor you will place here, right, to measure the voltage, and one sensor you will place here for to measure the current. Next will be here. Anything you are going to place this sensor? No. If you are not going to place your sensor, then how you can say what will be the voltage there? Even if you know the voltage, internal resistance of the inductor, how you know that? What about the diode? Here we are going to place some voltage drop here. What about the switches here? Again, we are going to place some voltage drop here. But the question is, we don't know these things. In simulation, in MATLAB, it will do, it will work. Because you are not going to consider all these things, but in practical, what you will try to do, so here you are going to place some big resistance here. Again, one voltage drop, you are going to place it for the switching losses, right? And another you are going to place here. And also here, this capacitor is not capacitor. You will see here, the capacitor will come with some resistance. It has a capacitor. So that's why whenever you will calculate the value of KPK and whatever, so those will match with the your hardware, exact hardware.
Typically, we make
Typically, it's that with that.
we make stateless matrix. We write the optimal values.
Yeah.
That is for same capacitor value to make same inductor value. Practical is the optimal values. Whatever
Right?
sorry, this side that's it.
Just try this. Yeah.
It's partial form optimization in order to optimize the weights of a neural net. So, will the system get affected when I'm going to change the acceleration coefficient value?
Omega.
Acceleration coefficient C1, C2.
See, in particle sort optimization, C1 C2 is not your acceleration coefficient. In particle sort optimization, omega is your acceleration coefficient. C1 C2 is going to decide your contribution towards your global or local. Remember the equation, what is the key equation of the particle sort optimization? I'm writing here, not for I'm writing the key equation of the particle sort optimization. Velocity, right? So this is your V T plus 1. Then you are going for Vt, right? So yeah, Vt plus you are going for C1 into rand. Rand 1 into bracket. Suppose this is your P base minus. Suppose variable x actually. So this is x. Then we will go for the C2 into rand 2 into G base minus this. This is a classical, but in modal equation you will see here multiplication of omega. You will see your omega. First of all, what is the value of C1 C2? You are saying you want to optimize this C1 C2. You want to change this C1 C2. First of all, you try to know what is the meaning of this C1 C2. Most of the time you will see C1 and C2 equal to the 2. Why this is 2? Why this is 2? Not 3, not 1. Why? See, here what is written? C1 into RAM. RAM is what? Random number. Random number in between 0 to 1. So average value of this is, average value of this 0.5. Yes. 0.5. And then you are going to multiply it. 2. This will be 1. 1 means what? No. 1 means you want to say that whatever your personal best impact you are going to face here, personal best minus 6, whatever impact you are going to calculate, 100% you are going to include in this variation. Similarly, same time here, C2 into rent. C2 into rent again, the value will be 1. It means whatever global impact you are going to face or calculate, so 100% that impact also you are going to include in your calculation.
So if that is the case, there are two more cases, right? One is self-tuned PSO and another one is construction factor.
Yeah.
So there we are changing these C1 C2 values to 1.49. And it is CST construction factor is equal to 1.48. So while going to that particular condition, will the system have any changes?
So,
The performance
yeah. According to my observation, I will suggest that what we should do, if you want to optimize C1 and C2, so you should maintain this one. You should maintain this. First, my solution is try to maintain this one. Even if you are going to decrease C1, increase C2 to maintain 4. So that overall impact is according to this 1.1, right? Whatever the impact should be. Yes, one side suppose you are going to take C2.3, so maybe you are going to overweight your global impact and the lower of self impact. So you can go for it, but try to maintain that. First, my suggestion is first one. Second, I will say within this C1 and C2 too. Don't worry about that. Try to optimize this omega, only one variable, and then see the values, how these values are going to match. But the what we are talking about, so over acceleration, this is the actual problem of PSO. This is the actual problem of PSO. Over acceleration. Over acceleration means whenever PSO starts searching, suppose this is your target, you are moving like this way, then it will be close to this, then it will not stop here, it will cross it, and then again back and then go like this. So here you can see some oscillation because of final solution. This is the issue with this PSO. This is the issue of PSO. This is the issue of PSO. That's why some other types of techniques are also coming in the market. What is yes, optimization. So we can use this optimization for what purpose? To optimize the variables in mathematics. To all these calculations. Not for the quality detection, not for the any health estimation and all that. It will not help you. It will help you in your mathematics. When you are going for a mathematics to calculate the power flow, loss flow, and all that. What should be the power, what should be the loss, what should be the load to match it. So doing that, you can use it. Next. The benefits, again, benefits in predictive analysis you can do by using your neural network. Automatic control means again, define the problem and then you can make the decision automatically. So that is enhance the forecasting. Enhance the forecasting is forecasting behavior you can enhance by using the complex mathematical optimization technique. So more and more variable you can include, more and more uncertainty you can include in your problem, make the problem complex and then go for the solution. Right? So those things you can do that by using this enhanced forecasting techniques. Next. So in the energy testing, so these things are happening by using this AI. People are using for that efficient energy production, right? Efficient energy production means you can plan properly and decide the power properly so that you will generate that. Otherwise, you will generate a little more, then your ADC will come down on the lower level. So those things should not be so like that. Energy efficiency. This is the reduced carbon emission. Reduced carbon emission means demand side management. If the overall load will decrease because of the 5-star rated improvements and something, then people will start using those type of things. Because of that, overall load will decrease and then your carbon footprint will be lesser because the electricity demand will be on the lower side. So we can think about that one. Reduce the cost. Cost will be related to the efficiency. And the safe working environment. Safe working environment is related to the you can say predictions. So predictive maintenance. So what type of fault is that? And according to the fault, your member will go according to that level of safety, right? What type of fault is that? And according to the severity of fault, you will take the action according to that. You make the plan for the maintenance according to that, right? So this is important. Next. Centralized energy management system. Centralized energy system is very similar to the MDM system, right? Interdata management system. This is that one. So through this way you can do that. You can use this IoT and you can use the AI. But yes, no one is using this currently. So everyone is planning to use it. You can use it, and after that use it. So you can take the decision, get the decision by using this AI algorithms. So AI algorithms will help you in this metadata center to decide the things. Yes, AI is using in the metadata center, but this IoT is not using currently. So these things we can. The concept side, then we see the central control, two things you see components level. So central control unit and the other side you see the data aggregation. And then user interface. Data aggregation is where you are going to store all those filtered data. And then user interface means with what rate you are collecting the data. What is the method here? Maybe the cellular method or maybe you are going for internet. So that is data collections and how you are going to communicate with the user. So that is those are the things you will see here. Mainly, again, this is advancement in infrastructure. If you have this, you will not require any additional things. You can go for that. Okay. So, central control room is for the entire platform. We can say that it will collect the data from different locations, not only the user side, as well as also you collect the data from the different research centers, and then it will use here to detection side, right? So,
Decentralized problem.
decentralized, yeah. So, how we can do it? Simple, you can, this is a one central control room, so that can just go for the local one. Then you, for example, Andhra. So here, make one central control for the Andhra Pradesh, and then similarly one central control for example, for the Madras or the Tamil Nadu. So, and both are communicating each other and sharing information. So we can say this is a decentralized control. But the problem with the decentralized controller is the decentralized you are going, so the area should have a ability to handle all those loads. So area has that much of power or not. The first important thing. Second, all your neighboring control centers, they are in your support or not. That is another one. See, because electricity is a very important thing to for the election point of view also. Suppose in the neighboring state, suppose government is BJP, in this state suppose government is Congress, suppose I am assuming. So this is the situation. When the election is nearby, right? And the commitment is every day 10 megawatts power will come from that state and fulfill the load demand of this local load. And the both are handling this decentralized manner. Then what will happen? When the election is closer, so that time that state will start cutting power. If they will cut power, you will face here our cut. And the local parties here, but they will claim our cut. People will face this issue and it will directly reflect in your vote. So that's why central control is important here. So central control, so that this local area politics will not interfere in these things, right? Yeah, some disadvantages here. If this here someone will attack, then entire system will be vulnerable, right? So this is the one demerit, but also some merit. How we can overcome these things? We can plan that. Because in the last 5 or 6 years back, one blackout happened in this country, right? Yeah. And because of what reason? Because of the policy reason, right? One side they want energy, another side regulations deny to provide them for the and because of that energy deficiency created the frequency loss, frequency mismatch, and then all those circuit breaker triggers need that. So that's why central control is important. So the government is also working on that. One nation, one grid concept, right? So this is based on those things. Next. And what is the benefit here? You see the holistic management. So the management side, so one center can take the decision and then everyone will utilize it according to that, right? So that time local party will not responsible for the electricity what is the electricity disturbance is happening, right? So this is also one good thing you can say for the local parties. improve the decision making system. So if you are going to use AI and all that, so definitely your forecasting and all this will become a higher level. So the decision will be also very important. Enhanced coordination. Enhanced coordination means you multiple generators you have, right? So all those generators you can easily plan that what amount of power you should generate at this moment and next moment this generator will generate this much of power. So like that way you can coordinate here, right? As well as your coal and all those things also we can use here locally. So suppose the some plants are in a Gujarat and coal is coming from Jharkhand. So see the distance, how much distance it is going to cover. Better way is that we can use that same well in the Chhattisgarh and generate the electricity. Electricity we can transmit from Chhattisgarh to Gujarat. Like that way we can see that. So the coordination is important for that purpose also. As well as for the renewable integrations also, this will be helpful. Next. And in these situations, this will come in the picture. The smart grid integrations will come in the picture. Right? So finally, in these situations, if central control group will handle all these things, so it will make a smart grid solution. So what is the meaning of a smart grid and microgrid? What is the difference between a smart grid and microgrid? Anyone? Microgrid and smart grid, what is the difference? Microgrid is
Okay, part is smart grid. It's not part in the smart grid.
part of a smart grid. Okay. See, when you are using multiple sources, then that system will be called micro. Simple. Means if you have the one source, for example, solar, so that is not a microgrid. That you can say distributed energy sources. If you have two sources, solar with battery bank, solar with wind with a battery bank, anything, or maybe more than two, maybe solar with hydro all together. So we can say this is microgrid. So inside the microgrid is based on the sources, number of sources what we are going to use, and then obviously all will work together. Means in a coordinated manner they will work. Coordinated control will be applied to work together. Yes, I know. So that is our microgrid. But inside the smart grid, it is not important to go for a multiple sources. If you have the multiple sources, it's okay. Otherwise, if you don't have, also okay. A smart grid is very similar like that. Because this is your advanced metering infrastructure. Only difference here is in this smart grid, the less impact on the your local load side. You will not include those portions. Means your household, your AC, how the AC is going to work, how your washing machine is going to work, how your smart devices are going to work. You will not include. Otherwise, rest all will be considered and the same advanced metering infrastructure. We can say this is your smart grid. Smart grid and a smart metering infrastructure are very similar like that. But yes, some extra thing is here in the smart grid. Here, control of all the generation will also consider. So we will also consider the control of the generation. But previously, we was very focused on the supply system. So supply is optimal or not, supply is safe or not, supply should be according to the load or not, all these things. But this time also we will focus on the generation side. So here, all generating plants are working together with all those uncertainties. So we also try to improve that and allow them to work together. So here you can see that this wind directly can integrate with the grid. This wind, this solar also integrate with the grid. So yes, here we have two options. Option one is that go with the daily commitment system. Daily commitment system is you have a solar power plant, then you will submit me 1 day ahead. So how much power you will supply tomorrow at what time? You will give a commitment for that. If you will meet the commitment, I will pay the money. If you will not meet the commitment, if you supply more than that or less than that, then I will take penalty. This is the commitment. So this is not a big thing. So what you will do, how you will tackle this? You will also keep one battery bank, which is power storage devices, and then you will come and suppose you will forecast, yes, tomorrow 10 a.m. I am going to generate suppose 10 megawatt. So you will keep the commitment of 9 megawatt. 9 megawatt. So what will happen? If the generation is still the 1 megawatt, you can use it for battery bank charging, and once you will see the generation is more than that, so yeah, generation is less than that, then you will discharge the battery and try to fulfill your commitment. So commitment based system will come to all these renewables and then it will go inside the integration. Direct integration, right? Like that. But again here some threats are coming. Some cyber threats are also coming with this all these renewable set. Okay? Cyber threats are also coming with the renewable set. What is that threat? Suppose you are the operator of solar plant. You are the operator of solar plant here, and right, and you are committing and you are feeding the power here. Committing the feeding. Ideally, you should use one battery bank to match your commitment whenever any uncertainty will happen. But since you are also a attacker, so what you will do? Attack. Because you are going to attack on the grid. It means here, suppose your commitment is 10 megawatt and your generation is 9 megawatt. 9 megawatt. Ideally, you should use one battery bank here and then discharge it 1 megawatt and supply it to the. If you are an attacker, then what you will do? You will not use battery. And then put the on it. Here is a road this house. And called industrial house, not industrial commercial building. Right? It is a commercial building. It is attached with the grid. Here generation is 9. So through the cable, you will take 1 megawatt from the grid, right? 1 megawatt. And through the cable, you will supply 1 megawatt. And this cable will attach here and supply the 1 megawatt. This is the power taken from the grid. The power taken from the grid side, and then adding here is supplying back to the grid. Right? This is attack. This is wrong actually. Right? But how you will decide that so the power which is coming here 10 megawatt that is exactly from the solar plant, or exactly from your battery bank and solar power plant, or somewhere they have taken power matching the commitment. Right? This is important. Cyber attack does not mean that someone will come from the Pakistan. It is not nothing like that. This is also wrong. Right? This is also wrong. And this is how things are going to happen. So in this situation, you can use the neural network to identify it. Because if someone will take the power from the grid and then feed inside the grid back to the grid, then you will see that the rate of change of the power will be very smooth, right? Very smooth. It will totally depend on the converter, not only the converter, sorry. It will only depend on the switch. When you are going to trigger your switch, power will flow according to that. But if you will go for the battery, so it will be a little bit service, right? Battery will take some certain time. And also battery voltage is fluctuating. Once battery voltage fluctuates, then your conversion, DC to basic conversion will also fluctuate. So through the pattern of the AC voltage, you can decide that. So the power is coming from the converter side, the power is coming from the grid side. But again, another problem. If this is the situation, then you will do another thing. You will take the power from the grid, AC. Use the divider to have DC, then another converter DC to AC, then get it. Right? So like that. So this happens. It happens. In India, so many operators I know they are doing this very frequently because they are not interested to invest money for battery banks, and they are committing others on the higher side. They forecast rock forecast. Rock forecast. 9 megawatt. Okay, 9.5. Higher side. How they are committing 9.5? Because they know the backup. They have grid as a backup. It means infinite source they have. Taking the power, taking this. So like this, the things happening. But yes, in this smart grid, we can allow on the basis of uncertainties also. Right, next. So in the smart grid side, whenever we are looking at the smart grid, again required here the communication channels. So that time this IoT will require the smart grid. And this is the part of this smart grid for the communication purpose. Currently, on the simulation is similar, but yes, this time we will go with the IoT system, and here we will collect the data in the real time, and then we will take the decisions. And this time, everything will be included here. Distribution line also included, transmission line will also included here in this communication system. So here we will also try to see the power variation of the transmission line, also on the distribution line, and on that basis, channel by channel we will use here for the planning purpose. Because here the transmission, why is transmission line? Because congestion is one of the other issue with the transmission line. Every transmission line will have a certain limit of the maximum power transmission system, right? So those things. So to monitor those things, this transmission line monitoring is also important for that. Distribution side again, distribution side transmission line monitoring is not important. Line power transfer capability is not important. In distribution side, reactive power in the distribution line is one of the important things because always in this third C one word is transmission lines are strong grid. Here the grid is weak. Distribution grid is weaker, and transmission grid is stronger. Always you will see this one. What this one? Why this is? What the meaning of a strong grid and weak grid? Both are connected with each other. How this is strong? How this is weak? This is because of the reactive power storing capability. If transmission, if the system have large reactive power storing capability, it means that is stronger. That is stronger. Reactive power capability, storing capability, reactive power capability is lower, so that is the weaker. So distribution grids are mostly you will see the weaker grids because whenever the reactive load will attach, immediately you will see the voltage variation in the near voltage area. Right? So like that. So that's why here monitoring is important for the reactive power. Monitoring is important for the voltage balance. Right? So for that purpose this is as well as other parts also like that. Next. Advanced control mechanism. So in these situations, what are the controls we can use it? So control in the grid side, you can use a dynamic optimization control, you can use a predictive control, or you can use the grid side. See here, every control has one purpose, right? For what purpose you are using? For example, you are going for the integration. Integration is synchronize the power into inside the grid. So for that purpose, the dynamic optimization is necessary. Right? Means you can just convert optimally and then create inside the grid. So you can go for that one also. Or predictive control. Predictive control is important for the grid supporting mode of operation. Grid supporting mode of operation means you will also think about the grid. If grid requires something, so you will also supply more into that. Suppose grid wants reactive power, so you will also generate reactive power and feed inside the grid. If grid wants linear power, so you will generate the linear power intentionally and fit inside the grid. So here you will see the grid supporting behavior. So this is your predictive control side, right? But in this situation, when you are going to dynamic optimization side, so this time your target will be only for renewable generation. So whatever solar power you have, just convert it to AC, synchronize with the grid, and follow the grid code and fit inside the grid. So those are things you will do here in this situation, right? And the grid structure management here. Third layer of optimization you will see. Third layer means here you will work in a coordinated manner with the other plant source. Means here you will not worry about, not think about the what you have to what you are going to do. You will also think about the other neighboring centers. So this much what power you are going to feed inside the grid is that power required or not. If power is required or not. For example, in a local area, in night 2 p.m. 2 a.m. you are generating 10 megawatt and feeding inside the grid. But grid demand is not like that. So that can you consider that as you will not feed those extra power on the grid. So the grid burden will be less, right? So here in this situation, dynamic response or additional demand side response will also consider. So here, so that's why you see whenever you go for a controller, you will see the primary controller, secondary controller, and third controller. Primary controller is only for the conversion. Secondary controller, here you will see the requirement and then you will control the power and feed inside the grid. And then tertiary controller is here, it will also analyze the situation of the requirement. And then you will go for the power calculation, then you will go for the power conversion, and then you will feed inside. Right? So this different level of conversion you will see. Next. Okay, because of this, whatever we plan different controller, different thing in a smart grid, what will happen here? Because of this real-time data integrations, you will see optimized energy dispatch. You will see here, right? And the lastly, you also have advanced control. You will see. What is the use of this real data integrations? Already you know what is this? What is the use of that? From morning and night, about this real-time data integrations. Optimize energy dispatch to get back we have discussed. So according to the location, according to the load, you will plan which line you should provide what amount of power. So this is your device dispatch, right? Because system is interconnected system. So here this planning is very much important according to the distance, according to the environment, according to the requirement, right? So this one. And then last one, the advanced control. Advanced control is mainly for the all those multiple converters or renewable energy which we are going to integrate. And in these situations, AI based control is very much important. AI based control. So one case example, one case study I want to show. So this is the one case study I want to show you. In this case study, here I will show you one control, AI based control. AI based control for the grid integration of solar panel. I want to show you. So here you will see, I am going to showcase you what AI based control. Here the AI is artificial intelligence, but here we will use neural network. So the neural network are two type of things. Usually a network, you can use the neural network for your liability prediction, create the liability, and then go for the matching, and then according to the match, you can take the decision and algorithm. This is the one. But those are multi-layer neural network. One is single layer neurons. Single layer neurons means they are not required any prediction, so any training data. Single layer neurons, right? See, the artificial intelligence is good, but if you will dependent on the data, so data should be right. But in every condition, in every situation, how you will get the data? Data is one of the biggest things, right? But here I will discuss one single layer neuron based control technique. Here data will not required. Only one layer of neurons we will use. This is basic mathematics we will use for the prediction purpose, and we will solve it. Next. Okay. So in this situation, what I am going to discuss, here you will see one solar plant, as well as you will see one grid side you will see, and another side you will see the controller based on the AI, single layer neural network, I am going to use. As well as you will see on the EV side, one node is EV, other side you will see some industrial or local nodes you will see. So these are the things I am going to consider. And the control will, the content of the control will be fulfill all demand. Means one side you will see the EV demand, as well as your residential load demand, and then your grid synchronization. Means the grid code will be followed, and then we will transfer the power inside the grid, right? So these things you will see next. So here target side, you will see the control. First of all, designing, then you will see the control. Then I am going for the maintenance side. Then finally your cyber security side, and then forecasting. Right? So the cyber security side, whatever data you will collect, data we will receive, and then we will process it. So that time, that is your own, that is one way this kind of that. Then finally you will see the forecasting. So here you will plan also. So what should be that, and according to that you will do this. So all these things will be over here in this control. Next. So the layout, this is our layout. In this layout, you will see this is a solar panel. This here you will converter, right? This is a converter. As well as you have a local loads also. So these are the home loads, and home loads may be the residential load as well as utility considered here, and then power data with the grid. Here they are not going to use any battery pack. The battery pack will not use. The target is very simple. If we have enough power, extra power, so we will set aside the grid, and the grid will be there as a source. When the power will be required, we will take the power from the grid. Grid will be here as a sink. So this is the objective of the system. Next. So here we will see the whatever arrangement we can go for that. We have the two options. One option is extreme inverter arrangement, another is your micro inverter arrangement you will see on the inverter side. But the micro inverter is a group of panel will attach with one converter, another group of panel will attach with another converter like that. Here you will see all panel together will attach with one inverter, right? Like that. So if you will compare these two things on the basis of losses, in this situation we will face the more loss. Here. In this situation loss is more, here loss is less. So here you will see the less loss, right? As well as complexity side is the control complexity. Here is the less because we are going to face with the one inverter, here you have multiple inverters, right? So on the basis of loss, on the basis of complexity, on the control complexity, we can say this one is the most reliable, right? But the merit here, where it is reliability. In this situation, suppose this is a 3-phase three-phase converter is 6 switches, right? And out of 6, suppose one switch is not working, then what will happen? Total system will collapse, right? Total system will collapse. But here, if one switch is not working of this converter, this group of converter will not work. This two panel will not work. Rest will be okay. Rest will work. So here you see the reliable operation. Another is suppose the plant is put over 1 megawatt, the converter should be also for more than 1 megawatt. But for more than 1 megawatt converter is again not possible. Right? So that's why this is not possible. So we should go with this one. So question is, in which system we should go with this? If you are going for a rooftop solar farm, so then you should go for this. If you are going for commercial purpose, this PV park and all, so that time you should work on that. Next. So the control objective, whatever control objective is here, simple control objective is DC-DC conversion and the DC-DC and like that. DC-DC conversion means go next. Next. Yeah. And then DC-DC conversion. Okay. One another problem with this system is, see, solar light is falling here, power is generating, using, and extra power is going inside. Right? But see here. This system is only for 8 to 9 ampere. So only this for this purpose it will work. Right? Next. And the rest 15 to 16 ampere power will directly come from the heat cell and we will reduce it. So on this basis we can conclude that what is the utilization factor of the plant? 1/3. Out of 24 hours, 8 hours of plant is working. So easily you can say 1/3 means 33% easily you can say utilization factor. 33% is also okay, but is it, if you are going to use your plant throughout the 48 hours at a full strength? No. Because in morning time irradiance will be low, so small amount of power will generate. In the day, in the middle of the day, irradiance will be on the higher side, maximum power will generate. Full strength, your plant will operate and again decrease and like that. So we can conclude that utilization factor of the plant is around 45%, more or less. Yes. 23 to 25 because of the solar radius pattern. Next. Yes. What is the solution? Network should be seen. Network is not.
In PD, in this PPT not available, sir. I will check in PDF files.
Don't worry, network will not visible. I make the network here. I know the network. Yeah, here. This one. Okay, this is the circuit. Okay. So this is our plant, right? So just this plant network is very important. So you can understand what are the components is not going to work for your 60 now. So this circuit. Next slide. Next page. Yes, this one. See this circle. All these things are not going to work. Just to see what are the things here. You have a panel. This side you have a capacitor, link capacitor. Another side you are going to use push converter. This is converter you are going to use. Next time again you are going to use this in capacitors. Then another this is inverter, and then you will see the filter. Then you can see inductors, and this all system not going to work for 15 to 16 hours. Right? Only for 8 hours this will work. In night it will not work. So easily we can use it in the night time also. Yeah, we have some option. Next. Yes. In night time, not complete circuit. At least this portion of circuit we can use it in the night also. Okay. How we can use it? How we can use it? you heard the word statcom? Have you heard the word statcom? Static compensator, statcom, statcom. What is the circuit of static? This is the transmission line. And then you are using what? Inverter. You are using one inverter. Here you are going for a one capacitor. And then anything else in the statcom means you are taking active power from the grid and converting your reactive power and feeding inside the grid. That is the task of the static compensator. You are taking active power from the grid and converting to the reactive power and feeding in the same grid. This is your statcom. Or you can use one small battery bank also here. If you have, you can use it battery bank. If you don't have battery, the task is take power from the grid. Which power? Active power. Convert it to the reactive power and feed inside the grid. What is the meaning of active and reactive? What is the difference? You take the active power, convert to the reactive. What it means? No, the conversion side is the waveform. When I go for the control, what I will do, try to do. Suppose I am getting the power, right? So this is the voltage, this is the current. Suppose this is your voltage, this is your current. I am going to convert this into reactive power. What it means? DA. Okay. Leading a line will depend on the see what is reactive power. If I go for the reactive power, what will be changed here? Only this will change. When the difference between the current and voltage is 90 degrees, that is your reactive power. Nothing else, right? So you will take this power and you will try to phase shift here. How much 90 degree phase shift you will try to maintain in your current? That's it. This is your reactive power. Plus 90 lagging, minus 90 leading, like that way. So only the target is phase shift 90 degree. And then your power becomes reactive power. Nothing else. So the control side only you want to do these things. Okay. If the statcom is this one, this is the statcom. Then see the line. This is your transmission line. This is your converter. Here is your capacitor. This capacitor, this converter, and then these are the filters, whatever attached to the load. This is an act as a statcom, or here you have a local load, then it can act as a statcom also. Circuit will be not different. Only if your load will attach, the load demands the linear power, then that time this inverter will supply the linear power. So that time we can say this is your DA. Nothing else. If load is not here, this inverter will generate only reactive power, and we will say this is statcom. Nothing else. Only load is coming here and demanding reactive power, so generate only reactive power, and we will say this is statcom. Nothing else. Only load is coming here and demanding reactive power, so we are saying okay, first of all I will try to provide reactive power. What is the meaning of reactive power and active power? Reactive power, what is this power? See, active power you know, reactive power you know. What is the third power, linear power? What is the meaning of linear? See, waveform, through the waveform is clear. Whenever you are taking active power, this means voltage and current both are in the same thing, right? Sinusoidal power, sinusoidal waveform, 50 Hz frequency, everything is like that. When you are going for the reactive power, what it means? Your voltage and current difference is 90 degrees, right? Waveform frequency is 50 Hz. Waveform is your sinusoidal like that. When you are going, then you will go for nonlinear. So that time your current waveform will be not sinusoidal. Current will be follow this different frequency component. Not 50 Hz, not 90. It will follow some other. Maybe 100 Hz, maybe 25 Hz, maybe 250 Hz. And you not only 250 Hz. It's a combination of multiple frequency components. Right? Means some distorted current you will see. Some distorted current you will see. Current waveforms are like this. This is not active current. This is not reactive current, right? So this is the combination of multiple frequency components. this type of power fault reactive. So non-linear power. So if load demands non-linear power, so that time we provide the generate the non-linear power, we will supply to the controls. Okay? So this is your base platform. So this circuit at least for 15 hour, 15 to 16 hour, we can use it as a statcom or DA statcom. Right? We can use it. Next. Next. Next slide. So here, suppose this is a circuit again. Here I want to say about this one. This is EV. Nowadays EV is also the trend, right? Everyone is thinking for EV, everyone is going for EV. Okay. Suppose here you are going to the EV. You are taking power, AC power here, and converting it to DC, then charging your car, right? So here EV is a load, local load, right? But the issue is okay. Next slide. Just assume your charger is this one. This is your charger. EV side charger is this one. Then what will happen? If EV charger is this one, then you will see that whenever you will convert it, next, when you will convert it, then you will see that here your voltage between the battery and this is pure DC. If not fully interested, you can ask any other questions. I will answer, no issue. Okay. So if you will convert it into DC, see, you are, I think you are all secondary somewhere, right? So not necessarily to understand entire system. Just pick one portion. One portion is enough for example. For example, this circuit is on your board, right? From my point of view, if you are able to simulate this one properly, then you can publish weekly paper at least 3. Just target should be to understand the problem of this circuit. If you are able to understand the problem of this circuit, easily you can publish whatever of paper you want. What is the problem of this circuit? Which I am going to discuss here. Current problem is here. Problem of this circuit is here. So if you will convert this AC to DC by using this capacitor of the battery, and here you will receive pure DC power. DC voltage and DC current. No issue about that. At the same time, when you see here, by the current you are going to assume this is the current wave. See this current wave. What is this current? This is your non-linear, highly non-linear. See, in this situation, you have two options. Option 1, use here 1 power factor correction technique. Power factor correction technique means required here one inductor and one switch, which will make this line pure sinusoid. The first option is that. In general, whenever you purchase a branded charger, always this type of circuit will come with a power factor correction mechanism. But if you are going for a cheaper charger like this, so this time your target should be to solve this issue locally here. How you will solve this locally? Next. How you will solve this locally? Because your load is here. Load is at this terminal. In this picture, load is here. Right? Load is here. So if here your load demands nonlinear power, so generate here nonlinear, feed here locally, so that it will not take from the grid. This is your grid line. But if I generate those power here and feed here locally, so it will not go inside the grid. So we can do that one also. So you will see here. See this charger or this any nonlinear loads demands nonlinear power here locally. So we will generate through this inverter locally and we will feed and sort out. This power will not come from the grid. There is a grid. This is the grid. So this is also one issue we can solve it here. Next. So in this situation, I am going to discuss one small control. So the control side you will see. Control side, what the control I am going to discuss. So mainly, first of all, before going to control, try to understand this BCC word. What is the meaning of BCC? BCC. Quantum common. Right? So we take a point where everything is going to connect, right? So point where the load will connect, a point where the grid will connect, a point where your source will connect. So this number will be called BCC point, right? So at this BCC point, we will try to match the power and simply the control will be based on that. Control looks complex, but it will not be complex if you understand the power balancing mechanism. So at this BCC, at this PCC, suppose this is your grid, right? This is your load, this is your load, and this is your solar suppose. This is your solar plant. This is your solar actually. So you can see that power is coming from this side. So we can say this is your P solar that is coming. Power is going this side. This is your P load. We can say that, right? As well as here we are going to use some power electronics converters, switches, inductors, capacitors. We are going to use here, and these components will also consume some amount of power. So we can say this is loss actually, loss across this circuit, right? So loss means what? Power consuming, someone consuming. It means we can say here this is your P loss. So means P solar minus P loss equal to the equivalent power here, right? Or this is your P load, and then this is finally we will decide the next power will be P loss. So same thing is written there in the top picture. One side PV power is coming, one side PV side power is coming. This is your PV power. Load power going towards the load, so this is outwards. This is P loads. Another side you will see the P loss again unit power, so that's why we get it as a load getting P loss power. And then at the end it will decide power will go inside the grid or power will come from the grid. Anything can possible. If this power is sufficient, for this load and this loss, then only extra power will go inside the grid. Otherwise, suppose this load is heavy and higher heavy load you have here locally, and solar condition is lesser, then what will happen? Power will come from the grid, right? Because this will be directly power can come from the grid without any control, right? So not required any control. Here we are not working with switch and everything. Simply grid power can come here to supply to go to the load, right? So that's why here you will see bi-directional and then here across the grid power. So it will depend this is positive or negative. Okay. At this PCC, at this point, what is constant here? Voltage is constant, as well as frequency is constant, as well as phase is constant. Because all these three things will be constant here, right? Because here at the right side, you are going to use your grid. So definitely all these three things will be constant. So just one time, assume your voltage is constant here. So if you will divide all this power to the voltage, I'm not talking about the sinusoidal voltage, means ds I omega, I'm not talking about that. I'm saying about the voltage magnitude. Just I'm saying dm. The voltage is constant, then divide all this power to the voltage magnitude. Then what will you get? Grid power divided by voltage magnitude. Then you will see here, grid current magnitude with the PV power divided by voltage. Then you will see the PV current, PV current magnitude. Why it is equivalent current? Because the PV current is DC. You are dividing with the AC side voltage. So this should be AC equivalent of the DC PV power current magnitude. This is that. Similarly, this is loss power divided by voltage means loss current. This is load power divided by voltage means load current. We can say that. Okay,
Sir, please convert the break.